Thanks so much, everyone, for taking the time to join us today. I'm Max Herzog. I'm Deputy Director of Cleveland Water Alliance, Deputy Director of Programs and Partnerships with Cleveland Water Alliance. We're one of the two convening organizations for this series on the state of HABs mitigation technologies. We're a nonprofit that's focused on supporting innovation in water technology, and we're doing this series together with the Great Lakes Commission and their HABs collaborative coalition of scientists, researchers, and agencies that are working to communicate insights and information about harmful algal blooms to the Great Lakes community. So we're really excited to team up on this series that's really focusing on the cutting edge of technology in addressing harmful algal blooms. In our last session, we talked about direct mitigation of HABs, and today we're going to be diving into mitigation of nutrient pollution. So really excited to have that conversation with y'all. Just one quick piece of housekeeping before we dive in. Really encourage you throughout the conversation to be dropping your questions into the Q&A in your sort of toolbar at the bottom. You may need to click the three dots to more to see. Oopsies. To see the Q&A. It is different than the chat, although it looks quite similar. But just want to call that out. If you enter it in Q&A, it'll let our panelists see it, and we will be going there first for questions. And we should have some time for conversation at the end. So again, really encourage you to drop those questions in throughout. With that, it's my great pleasure to introduce our moderator for today. We're very fortunate to have Laura Johnson, the Chief Science Officer for Michigan Department of Agricultural and Rural Development here today. And she's going to kick us off with a little bit of an intro for our speakers, as well as some background on our topic. So I'll hand it over to Laura.
Wonderful. Thanks, Max. And thank you all for being here today. I'm really excited to learn more from our panelists about ways that they have been thinking about in terms of mitigating nutrient pollution. I just want to briefly mention we have our three panelists, Steve Chamberland, who's co-founder of Water Warriors, Parker Cohn, who is founder at Performance Resource Management, and Steve Ostanek, who is president of Neundorfer. So I think each panelist will bring a unique approach to this, and so I think that we should have a nice discussion. Before I get started in asking our panelists a lot of questions, I wanted to mention a couple of things. First of all, it might seem a little interesting that someone from Michigan Department of Ag and Rural Development is giving this intro. And so just a brief overview. Since joining MDARD as Chief Science Officer, I've been tasked with establishing an Office of Agricultural Science and Research in the department. And as in doing so, you can imagine something under that title is probably taking on a lot of the wicked challenges in that natural resources, agriculture, and human health space for those things that require a cross-disciplinary approach. So nutrient pollution, especially in the Great Lakes, falls really into that realm. So that's the involvement here for us in thinking of these different approaches to nutrient mitigation. I would like to then jump in and give us a quick overview of nutrient pollution. Just to make sure we're level set, we're talking the same language, everyone sort of knows where the panelists are coming from. And I'll do this quickly because I don't want to belabor our point in hearing what everyone has to say here. So our quick reminder is that we're talking about nutrients. Now, for those of you who know who I am from my past work in Lake Erie, probably are thinking, oh, she's only talking about phosphorus. But as a reminder, for nutrients, we're talking about both nitrogen and phosphorus. Often they come in a variety of different forms. Nitrogen loves to swap between its hydrogens and its oxygens and likes to be in different forms, whether it's in gas or in the water. But we know that phosphorus as well is sometimes attached to particles and sometimes is dissolved. Those types of forms have a lot of effect over how they're treated and how they travel through our environment, their fate and ultimate transport into downstream ecosystems. Now, nutrients themselves are not harmful. They only become harmful because they cause overgrowth of organisms that give us troubles, especially in the human health realm. So thinking of cyanobacteria creating cyanotoxins, or overgrowth of bacteria like E. coli, especially when it comes to our beach closures, that very clearly can make us quite ill. So a great example of this when we think of Lake Erie is that, we know that Lake Erie loads are driven by dissolved phosphorus loads, so particularly one form of phosphorus that we are worried about, but that toxicity is associated with nitrogen. And honestly, phosphorus wouldn't be an issue if there wasn't so much nitrogen around for Lake Erie. So all of these things are intertwined in very interesting and complicated ways. So when we think of trying to fix anything, you can't focus on just one thing. When we think of sources for nutrients, normally I like to think of them in two different ways. We have waste, either from humans or animals, or we have runoff from land, whether it's fertilizers or manures. Manure is one of those tricky ones because it's both an animal waste as well as something that gets applied to land. So it can also look as like it's just the typical land runoff. Same thing with biosolids, right? That's something that's a human waste, but ultimately there is nutrient value in these products, and that's why they get applied to land. We have to remember that when we're thinking about nutrients, phosphorus is non-renewable and nitrogen is incredibly energy intensive to create. And so improving the sustainability and the reuse of these materials is good both for us as a society, but then also in terms of food security ultimately. We also have septic tanks that are a common source of nutrients, and those kind of fall in that funny gray area as well. If you have drain fields, is it runoff like land, or is it a pipe that's being regulated like a wastewater treatment plant? Not right now, thanks. Yep. All right, where are we? Sorry, they wanted to take out my trash and then I got distracted. So land runoff, we know, is one of our big challenges right now because it's driven by snowmelt or rain events, and these are very pulse nutrients that move quickly through the system. They go to downstream ecosystems to cause these problems that aren't always being generated at the location where they're happening. So there's this disconnect between where the eutrophication or the algal blooms or the E. coli might be happening, sometimes with more like point sources or our wastewater that can be happening at the location and causing problems directly and nearby to where that input is happening. So and remembering to think about the locale and where our issues are is also part of the complexity of this issue. We know that agricultural runoff can be the result of recent applications if you apply right before a rain event, or it could be past applications. So let's say you applied manure to one field over and over again for 10 years without ever measuring your soil phosphorus. If you don't apply again, it's still going to release phosphorus probably for another 10 years. So remembering that we're not always dealing with issues that are being caused in the moment, and there's legacy and time lags associated with these issues. And the final point I want to make is that our climate is rapidly changing. We're experiencing that right now. So we're getting more rain, so we're getting more land runoff. We're getting higher temperatures, so the receiving water bodies are warmer, which means we get more organisms growing, either it's E. coli or those blooms. This does not make anything easier for any of us. And so because of all of these challenges, I would say all of them just all together into one little funnel, we know that innovative and new approaches are really needed. This type of discussion is going to be required to advance progress towards sustaining our water into the future. Okay, now that I have said all of my spiel, let's move on to our speakers so you can hear from them instead of from me. So with our first question for today, and speakers, I'll remind you to review your technology and give a little introduction to yourself in this first question here. Can you speak to your perspective on the evolving state of nutrient mitigation today? How is new technology changing the conversation? And I'm going to let Steve Chamberlain kick us off.
Thanks, Laura, and thanks for the overview. I think what we've learned over the years, I mean, it's a significant challenge, harmful algae blooms, and there's a lot of stuff out there in the landscape right now where perhaps it's more treating the symptoms that we see rather than the source of the problem. And from our perspective, we develop Poseidon pellets, which captures phosphorus from water upon contact. But just going the extra step from just capturing the phosphorus, but also being able to reuse the pellets as a soil amendment or fertilizer, because as you mentioned in the opening, phosphorus is not only a depleting resource, it's a very useful, helpful element. So I think from our perspective, we're looking at the challenges, to be able to not only solve the problem, but also be able to harness a useful element so that it can be used for a beneficial purpose.
Yeah, thanks, Steve. And our next Steve Ostanek, did you want to answer that?
Yeah, thank you, Laura. I think we have solutions that are available to us, and one thing we've learned by being in the air pollution control industry is that if you wait until downstream, you might be a little too late. So we're taking the approach of and testing a solution that intervenes farther upstream, at the source on the farm, and you have a better chance of success with that. And we're using a pulsed electric field technology, and I wanted to just kind of share. Pictures are worth 1,000 words, so I don't confuse our audience. Just wanted to share. I assume you can see my screen.
I can.
Good.
Looks good.
Okay, good. So the pulsed electric field technology that we're piloting right now, actually, we just finished 3 full-scale demonstrations of the technology, is a way to shift manure treatment from a downstream liability to maybe an upstream opportunity, and maybe help transform the dairy operations. What is it? Just kind of imagine breaking apart the organic waste at a cellular level, and that releases or liberates the nutrient, in this case, phosphorus, so that it can be managed more effectively. And we're doing that without adding any chemicals, any massive infrastructure, or using a lot of resources to do it. And if we look at it as, or ask the question of, what are the long-term consequences, kind of take a systems approach here. We're trying to design this so that we avoid any unintended environmental trade-offs. This should allow, and to speak to Steve's point, is, there is, and Laura's point too, that you made earlier, phosphorus is a non-renewable. And if we can create value out of something, then the farmer benefits from that on their own fields, as well as benefits from maybe creating a revenue stream that they didn't have in the future. Because we allow that phosphorus to go to the bottom of the lagoon, and then that lagoon, that sludge can be harvested for future use and applied when appropriate.
Okay, and Parker, the floor is yours.
All right. Good morning, everybody. My name is Parker. I'm a mechanical engineer and founder of Performance Resource Management. So what we do is we regenerate soil using biology. So 3 things essentially create an opportunity for us, or job insurance or security: monocropping, fertilizer and chemical use, and tillage and compaction or overuse of a soil. So these 3 main things create this opportunity for a nature-based solution, which results from, we start with diagnosing what the problem is, because different soils have different problems. We've been managing our agricultural soils. Even golf courses and sports fields have been under different managers with different philosophies. And so different problems originate in those separate fields, farms, or golf courses. So we diagnose what the problems are and use prescriptive biology to regenerate the soil and solve the problems, whether it's salt toxicity or compaction or thatch or black layer, or all these nutrient lockup, solve these issues for our customers. And results of our program are nutrient reduction from higher efficiency or mineralization of nutrients from the soil to the plant, water savings via more water availability in the soil profile via better drainage and less runoff and evaporation, and also a higher quality and quantity of crops. So better nutrient absorption from the plant, between the soil and the plant, and also allowing us to have a healthier, more resilient crop. What I'm seeing in, as far as adoption work across, it's very different working with farmers to working with golf course superintendents and senior directors of field management for sports fields. But something that's very consistent between the three markets is they're very conservative, very slow to adopt change. But what I'm seeing is I'm seeing more new technology being explored by those more public-facing markets. So golf courses are seeing public criticism for their use of chemicals. And there was an article that came out about 6 months ago about increased Parkinson's rates on, populations living around a golf course. The conversation about artificial turf on sports fields and the health implications of that. There's much more, I'd say golf and sports fields have much more public view and awareness of what's going on. For instance, if you have kids at a sports field, I live in California in the Southwest, so we often have, signs that say don't drink the water because we're irrigating with reclaimed water, right? There's much more public facing information for these golf course and sports fields markets than when you go, comparing to when you go to the grocery store and you're buying, tomatoes or bananas. You have no real idea of what's going into that tomato or those bananas, where they are actually grown, come from, what chemicals, practices, how they got there, and what the environmental impact of those were. Where golf courses and sports fields are taking more risks, I think, adopting more technology, looking into drones, soil sensors, soil regeneration, like what I'm doing. And I've really seen the market move in the more public facing areas of golf and sports fields, and it's slower to adopt in agriculture. But like the harmful algal blooms and the conversation today, of all places, like I've had an incredible amount of interest from Florida, because Florida has major water contamination issues with, as Laura said, nitrogen, phosphorus, but also low dissolved oxygen in their water sources. So factoring in where do these harmful algal blooms come from, look at the supply chain, look at where did the phosphorus and the nitrates come from that cause the low dissolved oxygen in our water bodies. And if we can be more efficient upstream, right, use less, mineralize what's in the soil, and also be more efficient with every pound of fertilizer that we have to apply to maintain our monocropped systems, then we can reduce the nutrient load on harmful algal blooms down the pipe.
Thanks, Parker. Okay, so I'm going to take a moment right now to plug the Q&A. So remember, if you have questions, please put them in the Q&A spot so we can answer them both in real time or when we get to the end here. So our next question is, what limitations, risks, or other barriers stand in the way of implementing these solutions at scale? And have you seen any promising mitigation projects to fail? Let's see here. Who wants to go first? Let's go with Steve Ostanek first.
Thank you. I think there's three significant barriers that are out there. One is validation, the other is adoption, and the third is political will. So validation from a scientific standpoint and a financial standpoint is challenging. Every farm, in this case, we're talking about farms. Every farm is different. There's different weather, there's different waste characteristics, different operational practices. All these things vary all the time, and that makes validation challenging. And that's also why initiatives like H2 Ohio and the willingness of the EPA to fund pilot projects is so important, to this process. Another barrier is adoption. Adoption is part of innovation, and we have to develop incentive structures that work for the stakeholders in the group, and in this case, the farmers. And we have to be able to show how these technologies can be implemented without creating a large financial burden on the stakeholders. The third, political will, or the lack of it, can make or break, any of these technologies. Over a decade ago, our technology was applied in this very similar scenario, and it wasn't successful because the science didn't work. It was not successful because the political will faltered and prevented it from proceeding.
Parker, do you have more to add? Thinking of up on the agricultural side of things.
Yeah, absolutely. So kind of bridging off of some of the things that Steve said, validation and field testing is really challenging in agriculture, and agriculture doesn't happen in a vacuum. So one of the challenges I see technologies face is, we go out and we do a project where there's literally 40% less water used on the water meter, right? And 70% less nutrients used on the sports field that has been grown by the same person for 20 years. Yet there will always be scrutiny, right? An eyebrow being raised to these changes. Oh, well, the weather was or we had a bit more water. And a lot of these we have so much capacity to collect data now. We have more data than it's almost overwhelming. But one of the things that's really beneficial, and I think what we have to lean into in agriculture, is historic yields, like leaning into average historic yields going back 10, 15 years is pretty standard for crop insurance. And looking at what our inputs were then, what our outputs were then, and then what technology have we adopted and what has actually changed in the field. What have we done to our yields? What have we done to our nutrient applications? And I like the main thing that I see as a challenge is agriculture has become more monopolistic, or smaller farms, the ones that are more incentivized to, because it's either tread water or sink, really, and they're really forced to adopt technology to keep the lights on. They're being bought up by the larger ones, making it more private and more restricted from the public view, kind of getting back to what I said before about what fosters innovation. And economies of scale allow these farms to operate the same way they have without incentive to do anything different, because they have, tens of thousands, hundreds of thousands of acres in some cases. I'd like to see competition come into place somehow to encourage nutrient reductions and adoption of technology that reduces the nutrient load and chemical applications at scale, to somehow gamify where if you're using 20, 30, 40% less inputs while maintaining or increasing your yields, for instance, like it would be cool if we had some sort of program that would kind of gamify being more efficient from a environmental and a health perspective, from our being the end consumer living on this planet.
All right, I'm gonna write that down. Gamify efficiency in farming. All right, thank you. Steve Chamberland, what types of limitation risks or other barriers have you seen in terms of implementing solutions at scale?
Yeah, I think I'd echo a lot of what the others have said. I mean, in water, the industry as a whole is risk adverse, as it should be. I mean, it's a very important resource. We really need to know how we're treating the water. And so to go through all those steps is absolutely necessary. So regulation is definitely a part of it, and having to go through that process and doing it the right way, so that there is confidence and understanding of what this new innovative technology is. And being able to put yourself in the right places, right? I think the awareness factor, I know when Parker was talking earlier, and maybe it's some of those forms, but the conversations around this topic are much different now than they were even about 5 years ago. So I do think the awareness is there. Our Poseidon pellets are very versatile, so we have conversations in a lot of different markets, whether it's agriculture runoff or wastewater treatment facilities, both municipal and industrial. as well as, stormwater, lake and pond management. So there's a lot of different conversations that we have. We talk to a lot of different people, but the reality is we need to be talking to the people that there's a higher percentage of action that's going to take place. And what we find is not only is it awareness, but you also, the areas that have some sort of regulation and enforcement on, discharge limits of phosphorus in particular into the water, or different incentives, whether it be, violations that are, a potential, or if there's other ways to incentivize action, because I think that's when you start to move the needle a little bit more. And we're starting to see progress. I mean, we have a project that'll be coming online in the United Kingdom, wastewater treatment facility. It'll be using 60 tons of Poseidon pellets, but that was about 2 years in the making. A project down in Florida, which it's been in the works for over 3 years, should be coming online in the next several months. So it's a long game. It's a long process. But I think the good news is there's a light at the end of the tunnel if you're able to keep kind of going through the steps, which are, in our opinion, absolutely necessary.
Okay. All right. So we only have one prescribed question remaining, and that is, what does the future of nutrient mitigation look like, and what could successful scaled implementation of this technology enable? So how about we get started? Who hasn't? Maybe Parker, do you want to go first this time?
Sure. So the future of nutrient mitigation, I really see a lot of policy influencing what nutrient mitigation is. Like golf specifically in Florida is really, there's some policy that's going to go into place in 2030 that is extremely aggressive regarding nutrient use and mitigation. And we see, in California, the Coastal Commission, we have a lot of regulations and policy that push it here. But I think one of the bigger things, I don't remember the statistics off the top of my head, but it's like 8 out of 10 products used in the United States like aren't allowed to be used in Europe on playing fields or something, which is crazy. So we're talking about fungicides, herbicides, insecticides, and the chemicals that we use to treat nematode issues in the Southeast. And we also are starting to have nematode issues on the West Coast as well. But these chemicals are extremely toxic. And so with the current administration and the direction everything's going, these managers and decision makers that are managing, somebody who manages 100 golf courses, billions and billions of dollars of asset, we see them looking to the horizon of how are we going to displace this once it's gone? How are we going to control these disease issues once these drugs are no longer available for our use? They're not on the shelf anymore. So I think and that's more on the public facing side of where the land managers are looking ahead, but it's being pushed by policy. It's the threat of losing the tools, right? And having tools taken out of your toolbox that is really driving the movement for nutrient mitigation from my experience.
All right. Steve Chamberlain, you can go next.
Yeah, I think again, I'd echo some of those things that Parker said. I do think that there's a lot of really good studies. There's a lot of really good information, and I think not only just the technology of treatment, but the technology of monitoring and understanding the problem even at a deeper level has come a long way, which then naturally has you start asking questions of, well, is this chemical the best way, to try to solve the problem? And I think as the problem, continues to grow, and we're seeing algae blooms in areas that never used to deal with them before, and certainly that's just the the byproduct of the warming temperatures of the water, and then all of a sudden the nutrients have always been there, but now the conditions are just right, and now you're starting to see blooms in areas that you haven't before. So there's more and more of these treatment methods are being used, and exponentially more of the products being put in the water, and then what kind of environmental impacts are those starting to show, or are we now able to measure and make sense of that maybe we weren't able to before? So I do think the trend of really going in the direction of nature-based solution type methods and technologies. And then of course, I think in many industries, if you're not being really thoughtful on the materials and the products and the things that you're using to either be able to reuse or to be able to capture and reuse and find beneficial purposes, I think that for sure is the future. And it's not because it's because it's a necessity, right? We're getting to that point where there's a lot of different studies you can look at. The numbers start going down as far as when we might not have access to some of the things that we've been accustomed to in our normal everyday lives.
Okay, and Steve Ostanek, you want to wrap us up on this one?
Yeah. I think it's important when you start looking at the future of scale and implementation that we think beyond technology and the application of technology and look toward a kind of like ecosystem enablement. And if we think about nutrient mitigation as a compliance exercise, we're probably missing the boat, missing some opportunities. If we reframe that as a system optimization challenge, where it creates value for the stakeholders, it improves water, it reduces long-term costs, I think that kind of liberates the thinking, and maybe even gives some people, even more hope that things could be done. Right now, we're seeing, and this is from our recent learning in this area, is there's alignment between public funding and private sector investment in R&D and interest in the stakeholders. That's a formula for scale, but it's not enough to take it from pilot to practice, and that's where we got to get to. And I'll go back to something that Parker said earlier about validation. We have to change our thinking from I'm at a 0 now and I want to get to a 10, and we're missing the 2s, the 3s, and the 4s in between there that are starting to move the needle, right? And this is not it's not a home run. It's not one thing is going to do this because of all the variability that's out there, right? And if we look at if we get to a 3, that's great. What can we do? What can we use? What other technologies or practices can we use to move it to a 5 and kind of just continue down that continuum?
Nice, thank you. So we have a number of questions in the Q&A. A few of them are around the topic of manure and improved manure management. So I was hoping that maybe each one of you, if you're feeling so willing, would like to discuss in a little bit more detail about how you reduce the nutrients associated with manure, either when it's in a waste, as waste in a lagoon, or if it's being applied to the land. How are you making sure that maybe the nutrients are less, or you're preventing runoff? Like anything along that sort of continuum of generation to use. And I'll any one of you can go first. I don't know which one would want to. Maybe Steve Ostanek, since you have technology that's directly in a lagoon, you want to go first?
Yeah. Where do you want me to start?
Well, there has been some requests here for a little bit more detail on how that operation would work anyway, in terms of finances and costs, and then how does it get to the point where you're actually reducing potentially phosphorus or nitrogen from entering waterways?
Yeah, no, it's, from an application standpoint, one of the things we have to be aware of, and it's not just farmers, but we'll talk about farmers because that's the context that we know now, is you don't want to burden an operation. So whether it's a farm, whether it's a golf course, whether it's a wastewater treatment plant, you don't want to burden that operation with additional uh, operating headaches or costs and that. So I think, from our standpoint, we have a very simple technology. It's we can on all three pilot demonstrations that we did, probably within 4 hours, we had the system up and running. And over the period of weeks, farmers were telling us, if I didn't have to pay attention to the generator, and this is a temporary installation, so we had to have a generator. If I didn't have to pay attention to the generator, I wouldn't have to pay attention to this thing at all. So to them, that's kind of validation. It's like, hey, this is not going to create a burden for me. And so we just need we need some electricity, and away we go. With that. So I think we have to be super sensitive to that, how we apply these things and what are the true costs, that are going to be incurred. We feel that this is a super low cost. We're talking cents per gallon of treatment, for cost involved with this thing. The other challenge that we're faced with is this is not something that, in the case of a farm, you need to have 24/7. You just need to have it at certain periods of time during the year prior to spreading. And, that to us is more of a service than a capital equipment purchase for the farmer.
And then ultimately, as a reminder for the audience here, once you've used your technology, but prior to spreading, then that would ultimately reduce at least the amount of phosphorus in the water that would be used and reused, and then it would concentrate it in the sludge in the bottom. So then you can be more careful with your application. Is that the general approach?
Yes, that's the approach. And at the appropriate time, a lagoon could be cleaned out, and then that phosphorus rich material could be applied to the fields at an appropriate time.
So it increases the storage of that material, so you don't have to apply it the wrong periods of time, which we know can always lead to more runoff than we want. Perfect.
Right.
All right. Okay, I'm going to pass on to another panelist if they want to tackle this manure question. Either one of you feel like going first on this topic? Parker?
So with manure, so I've got some experience working with dairy farmers on the dairy side. I can't really speak to the other sources of manure, poultry or anything else, but one of the things on the agricultural production side that can help mitigate waste is feeding, growing higher quality alfalfa, feeding the animals, having their feed have higher feed values, higher protein to ultimately produce less waste. The high-end dairy farmers buy A1 hay. Like they buy the premium. It's kind of like you're at the gas pump and you select high octane. It's like the folks who are running big dairies really looking at managing waste will use feed quality and spend more money, on higher quality feed, which has a bunch of additional benefits, right? If your animals have higher quality feed, they're going to have better immune systems. They're going to have higher quality product and probably more of it. They're going to have less waste, coming out of each cow. That's expensive to process, has a lot of environmental, consequences to it. That's the main when we talk about fertilizer, how they use it, I guess. as well is when we start making applications of fertilizer to the soil, taking or applications of the dairy waste to whether it's sludge or slurry or whatever, and we're injecting it into pivots and putting it out on fields, like that is essentially free fertilizer, which can be beneficial for growing crops, but a lot of the nitrogen and the nutrients in the manure isn't readily available. It's why like composting has become such a, has taken the industry by storm out here. You have to order your compost. If you want serious compost on your fields, you've got to place orders for it 6, 8, 12 months in advance to be able to get the supply to amend your soils. So in that scenario, the dairy waste is moving to the compost facility to get broken down, essentially taken to a higher quality, and then sold at a higher price to the farmers to essentially regenerate not regenerate, but amend their soil in more available, bioavailable forms of nutrients that results in, higher feed quality over time. So my experience with working with manure generators is predominantly on the dairy side, and those are the trends that I see kind of happening on the waste management side.
Yeah, I think oftentimes when you think of application manure to land, it's as, the challenge happens when you're being applied it as a waste, and so turning it into the resource that it really is and having value associated with it should certainly help people sort of reframe their views around that type of phosphorus or nitrogen. So, and Steve Chamberlain, I want to give you an opportunity to chat to you.
Yeah, and I'll keep it short because for us, it would be, if there was a runoff from an area where there might be livestock or something of that nature, because if solids are caking up on the pellets, then it's going to impede their performance in capturing phosphorus. So we find ourselves in areas where the solids aren't. But we've also had plenty of conversations with other different treatment methods, or even anaerobic digestion, or even lagoons and things where there might be something that's taking place. I know Steve mentioned, dredging a lagoon. It's a good example of, when you dredge it and you dewater it and you have this, phosphorus-rich water, where is that being discharged to? And so, we can get involved in areas like that. And I think with a lot of different problems out there, sometimes it's multiple technologies that you're able to integrate to really get the best results.
Thank you. So since we've been talking so much about recovered phosphorus in particular, there was a panel question about if anyone is looking at non-agricultural use of that recovered phosphorus, the couple of examples being flame retardants or corrosion inhibitors, but there could be a lot of other options as well. Have you guys been hearing about that aside from reusing as fertilizer? I see a lot of head shaking, so I'm going to say that that's probably a no. But it is an interesting thought because we know a lot of phosphates used in the drinking water process to, protect pipes for corrosion that ultimately would end up in our wastewater treatment plants to get removed before it's discharged into a waterway. So.
Laura, that is an interesting question, and probably just haven't thought about it much, but it helps with the financial adoption, of technologies. And if you're only looking at, okay, what if we can only use phosphorus for agriculture, then my box is this. But if it's for drinking water and other applications, my box is bigger than that. And so that's a good question. It's a thought-provoking question for us.
Yeah. Let me see here. I have a nice long one here in the Q&A about work on cost benefit as it relates to reducing the need for external inputs. I think, Parker, you were talking about this a little bit more, but you might want to add a little bit more to it. The question is, at what cost point does it become more financially feasible for farmers to reuse local nutrients rather than import commercial fertilizers?
I can speak to a little bit of that with what we do with my business with regenerating the soils. We're able to typically displace the use of displace the use of additional inputs and mine or make available what's already in the soil. So every farm's going to be different. The way that every farmer has managed their soil and the inputs that they've used and how they've used it, the crops that they've grown, the crops that they've cycled, all of this factors into what the nutrient load in that specific soil, what we're going to be able to do to displace, nutrient input. One of the bigger challenges, I know this is cost benefit, and cost benefit has so many different nuances going into it. But there is financially feasible ways to displace nutrients, but it also comes down to the education level of the farmer and their willingness to change and adapt. Like, how are we making decisions on the farm? How are we, for instance, I work with a lot of tomato farmers. We take petiole samples weekly to determine what nutrients get applied. Well, the folks who are making the decisions on literally 300,000 acres of tomatoes a year, they're looking at the plant. They're not looking necessarily at the soil, but at the beginning of the year. So even if there is phosphorus in the soil, they're typically going to look at the plant's deficiency or where they want the plant levels to be to make these decisions. And I think part of a strategy in the cost benefit analysis is looking at the big picture, is holistically looking at, okay, the whole system consists of the soil, what's in the soil, what's in our agronomic plan, what are we putting into the soil, and what is showing up in the plant. You can often see, deficiencies in efficiency between the soil and the plant that have these opportunities to reduce phosphorus loading. There are products, there are services, there are technologies that can help with that. One worth calling out, I got a long response going to the golf specific question here, but another source of nutrients is the water source. So part of my job and what I'm doing with my almost every customer I work with is, are we quantifying the nutrient load in our water source as part of the agronomic plan and the total nitrogen, the total phosphorus applied over the course of a year? And oftentimes the nutrients that are in the water are not available, so they're not really factored in. So when we go to, how do we make the cost benefit analysis to offset our input use? I'd say and that's part of the process of what I do when I onboard a customer, is I look at their water, I look at their soil, I look at their agronomic plan. And when I see opportunities for reduction, for instance, we have 2.5 times the amount of nitrogen that the plant needs going in, like based on, nitrogen demands and studies on the specific type of Bermuda grass, for instance, right, over time. The biggest challenge is the education and the resistance to change, doing something new, trusting, a new methodology that the farmer's been, doing the same thing for 30, 40, 50 years, sometimes longer if it's a multi-generational farm. But I think that's the best I can contribute to that cost benefit question, is kind of share a little bit about my approach and go from there.
Anybody else want to contribute more on that? Okay.
If I understand the question right, I think the other thing, and I like when Parker was saying, really look at, the big picture, the whole picture. And I think one of the other things to look at is where is this reused phosphorus coming from? Because it might also be solving a large problem for that stakeholder, which might have a hefty price tag that they're dealing with. And if there's a way to then, be able to have that reuse option that's also going to save, where the phosphorus was being generated from, save them money or time or convenience or whatever it might be. So I think, that might also play into the cost benefit.
Okay, so before we go into the very final question, what I would like to sort of bring up real quickly is this idea. So we've been talking a lot about sort of a bit on the public facing side of things about how, if there's a public viewpoint, then, like you see that change happen more, or, we talked a bit on the reclamation and the manure and all of that side of things, but I was kind of curious of your thoughts on the role of consumer-driven change over a typical sort of incentive-based or other types of approaches. Have you had any experience that consumer-driven changes have helped spearhead any particular technologies or helped any of your projects sort of get up and running more than you would have otherwise?
I think you do have, like in some markets that we're in, I mentioned before, a lot of times it's the regulation, it's the enforcement, and that's what's driving the action. But, there are those rare individuals that are really just looking, to do things the right way, right? And they're exploring something that is environmentally friendly, that they can see that it's a better method and in a more environmentally friendly method than what they've been doing. And so they're willing to then try, right? They're willing to create the action on their own because they want to do the right thing. So that I think maybe matches up with, if you call them the consumer, they're then buying, right? They're buying the product that they then are doing that because of those reasons, not because of some enforcement or regulation.
Anyone
Yeah,
else want to?
I think anytime when you have the consumer drive the action or drive the behavior, things can change quicker at that point. And there's lots of examples out there in various forms. In this specific case is the things that we're talking about. There's a lack of awareness, I think, of what the challenge really is. They hear sound bites, and in this case, the sound bite that they may be hearing is, "Oh, we're beating up the farmers again. They've got a problem, and they're just sticking their head in the sand and not dealing with it." And that's so far from the truth on that, but we don't know what that problem is, right? So someone in the Q&A had asked a question around the engagement of farmers, and I think if we look at farmers as that consumer, right, they're very engaged. I mean, that was surprising to us at how engaged they are to tackle the problem, the challenge that's at hand. They may not know what to do with it, and they may have constraints around their operation, but they're very open-minded. As being a conservative group as they are, they're very, very open-minded about this thing and willing to do something to try to help.
That was a lovely segue, Steve, because I was going to bring up that question about the engagement and interest of farmers and adopting new technologies. So that might be a nice switch over into thinking about that. And unless, Parker, you want to also talk about consumer-driven change as well. So I'll let you kick it off.
It's kind of a hybrid. It sounds like it's kind of a step into your next question, was what my response is going to be. But consumer-driven adoption from the scope of soil regeneration, and my experience in all markets, agriculture and specifically in agriculture is being driven more on the land owner side. And so I've gained a lot more traction working through the water districts, or working with, not really working through, but working with, because the water districts are in the business of securing a water supply, right? And so when we see the water district leases the land to the farmer for 5 years, 10 years leases, and when the water district includes our technology for the consumer, it's almost just the tone of the engagement. The entire relationship is off to a different start. It's not combative. It's not really questioning. It's entirely educational. And that service that's kind of, funded for by the water district allows the consumer to be, to not be guarded, to really be open. And it's so much more pleasant to work with folks who are just really excited to work with you rather than having to make a sale. And they're excited to learn from all the experience of the water district and the liaisons that's job is to, manage this property. And I think that kind of goes into your next question of like how's policy going to affect it. But I'll end there. I'll cap it off there. And if there's anything to highlight in the next question, we will.
Well, really, we only have 2 minutes remaining, and so what I was going to switch over to was, we can talk about policy or regulations in the next 5 to 10 years if you want to give that, or if you would prefer. I was thinking any last final thoughts of something that you wanted to mention related to innovations and technology associated with nutrient mitigation that you haven't had a chance to be able to speak to yet. And maybe Steve Chamberlain will let you go first and quickly.
Yeah, and I think there was a question in the chat as well. And what I haven't mentioned to this point, that the Poseidon pellets were developed through a cooperative research and development agreement with the US EPA. So it was a 3-year process from taking these naturally occurring mineral materials and then pelletizing them, to do what they do in capturing phosphorus from water. So the EPA was adamant that we were not going to cause another problem by trying to solve a problem. So with those naturally occurring mineral materials, the ability to then reuse, we were also in studies with the USDA that we're working very closely with, growing corn and fescue grass to show the beneficial reuse of the pellets.
Steve Ostanek.
I'll just add in there is actually a part of a question that's in the group of I think we shouldn't be afraid to use public funding to try to jumpstart some of this stuff and gain momentum. I mean, that's how all kind of technologies. It's that quasi public-private synergies that happen, and if we can do that, some of these things can come to fruition faster, and maybe that scale. The scale curve is not as steep.
And Parker.
We didn't dive into it at all, but the Farm Bill. I would like to see the Farm Bill be put to more diversified use, and to build on what Steve said, is to actually put more of that into funding innovation, is to funding technology and actual farm trials, because I've gone out and split probably 50 or 60 fields in half over the course of the past 15 years to demonstrate the technology. But splitting a 50-acre field or a 100-acre field in half is nothing like doing 5,000 acres, right? Or 10,000 acres. And it's much less difficult to refute when you have the scale behind it. So in our ability to use public, funding, in order to use funding from the government, taxpayer dollars, to prove out technologies, right, at scale that can have a massive impact on nutrient load, quality of feed, environmental, benefits. I'd really like to see that start to happen.
Okay, so we are certainly at time now, so I'm going to wrap us up here and just thank our panelists for giving all of their thoughts. Clearly, you guys have been working in this arena for long enough to have some really thoughtful ways of us considering how we can improve nutrient mitigation through innovation. Really is our goal here. And so with that, thank you all for joining us online. If you have any follow-up questions, I'm sure you can get them to our colleagues here at the Cleveland Water Alliance, and they will ensure they get to one of us